Hello everyone, in this video we are going to learn what Menelaus' theorem is, and then we are going to solve a few examples about Menelaus' theorem. So, let's start drawing a triangle. Let's construct a triangle, any triangle. Let's say this is the triangle ABC. So I'm going to extend one of the sides of this triangle. Let me extend the side BC. So I'm going to extend BC and then I'll get the point D here. Another line segment from point D to the remote side of the triangle. So from the D, I'm going to draw a line segment to AB. Now we have this figure. Let me call this point E and then this point F. So the Menelaus theorem tells us in this figure DC over DB let me write DC over DB times BF over FA times AE over EC is equal to 1. Alright, let me explain one more time. This is our principal triangle, ABC, the main triangle. So we have extended BC to BD. Now we have the point D. From D, we are going to draw another line segment to AB. Now we have this line. Alright, so the theorem tells us DC over DB times BF over FA times AE over CE or EC is equal to 1. Alright, so let me explain the theorem in another triangle. Let's have the triangle ABC. This is the triangle ABC. So this time I want to extend the side AC. So let me extend AC. So I got here the point D. And then from the point D, I am going to draw another line segment to the remote side, which is AB. I'm going to draw this line segment. So let's call these points E and F. So the Menelaus' theorem tells us from this point, because we have extended AC to AD, from this point, I'm going to go from D to C first, which is DC over, and from D to A, DA. Be careful, not DC over CA, DC over DA. And then AF over FB, AF over FB. Be careful, not AF over AB, just like in the first one. In this time, AF over FB, and then BE over EC times BE over EC is equal to 1. Okay, so let's solve our first problem. As you see in this figure, we have the length AF is 4, FB is 3, BC is 3, CD is 6, AE, which is the question, is X, and EC is 2. X is equal to 2. So in this example, let's say that this is our principal triangle. FBD is our principal triangle. So that I extended BF, I got A. So in this case, from A, I'm going to go to F, and then from A to AB. So I'm going to get this. AF over AB, which is 4 over 7, times BC over CD, which is 3 over 6, times DE over DF, DE over EF, is equal to 1. Normally this is correct. The Menelaus theorem tells us 4 over 7 times 3 over 6 times DE over EF is equal to 1. But this is not enough for us to find the value of x. So what should we do here? Alright, so let's look at the problem from another aspect. Let's say that this is our principal triangle. This triangle is our principal triangle. So I have extended this side and I got this point. And from this point I drove a line segment to the remote side of the triangle. So in this case I have to start from this point. So this case 6 over the entire side, which is 9. 6 over 9 is equal to now 3 over 4. Be careful, not 3 over 7, 3 over 4, 6 over 9, 3 over 4, and x over 2. X over 2 is equal to 1. Now we can find x. So we see here 6 times 3. 6 times 3 is 18. 18 divided by 9 is 2. Or we can do this. 6 times 3 is 18. 9 times 2 is also 18. So 6 times 3, 18. 9 times 2, 18. So our expression simplifies to x over 4 is equal to 1. So we can do the cross multiplication and we got x is equal to 4. Okay, so this is our next problem. In the figure, we are going to find the length of x. The length of x. So let's try to apply the Menelaus theorem. So let's start from this point. And so we can write 4 over 8, 3 over 6, and 6 over x. We can write this. If you start from this point, you have to write 6 over 9, 4 over 4, and this side over this side. But we don't know the length we don't know the relation between these two sides. So again, we are going to start from this point. So we may think this is our principal triangle. So I am extending this side, and then I am connecting this point. I'm going to draw another line segment from this point to the remote side. Okay? So now I'll do 4 over 8. 4 over 8 is equal to 3 over 6. 3 over 6 is equal to 4 over 8, 3 over 6, 6 over x. 6 over x. 6 over x is equal to 1. Okay, so 4 over 8 we can simplify to 1 over 2. So 3 over 6 we can simplify to 1 over 2. Now in the numerator we have 1 times 6, which is 6, over. In the denominator we have 2 times x. 2 times 2 is 4. We have 4x is equal to 1. So the cross multiplication, we get 6 is equal to 4x, and we divide both sides by 4. So we got x is equal to 6 over 4. So when we simplify 6 over 4, we are going to get x is equal to 3 over 2. X is equal to 6 over 4, so x is equal to 3 over 2. Alright, let's try to solve this example. So here you can pause the video and give it a go. So if we start from this point, actually we have two possible situations here. If we start from this point, we will get 5 over 5 plus x, AB over BD, and DE over EF. But if we start from this point, from the point B, we will get DB over DA, AF over FC, CE over EB. When we multiply these, we will get 1. Right, so you can give it a go first. Let's look at the given information. AB is equal to BD. This is given. So if AB is a unit, then BD is also a unit. And DE is equal to 3 times EF. So let's say that EF is B unit. So DE is going to be 3B unit. EF is B and DE is 3B, because 3 times B is equal to DE. Alright, so we have to find X. What is X? Alright, so we should do this. We should start, let's say that this is our principal triangle. Look at the triangle ADF. The triangle ADF. So we are extending AF. We are extending AF so that we get C. And then we draw another line segment from C to AD. So we have to start from C. So 5 over 5 plus X. 5 over 5 plus X. Let me write that here. 5 over 5 plus X times A over A, because they have the same length. A over A times DE over EF, which is 3B over B. 3B over B is equal to 1. Okay, so the first thing we have to do some simplifications here. A over A is equal to 1. So B and B cancels out. We have 3. So in the numerator, we are left with 5 times 3. So 5 times 3 is equal to 15. 5 times 3 is equal to 15 over. So in the denominator, we have 5 plus X. And as you know, these are 1. 5 plus X times 1 times 1. We are going to get 5 plus X. 5 plus X is equal to 1. Is equal to 1. Alright, so we can do the cross multiplication here. 15 over 5 plus X is equal to 1. So 15 is equal to 5 plus X times 1, which is 5 plus X. And then we can take 5 to the left. 15 minus 5. So X is equal to 10. So here, in this example, the length of the X, or the length of AF, X is equal to 10 is the answer.